Um, Hi, my name is Carly. I'm going to talk to you about Google Cloud. So first, I'm going to tell you about me. I'm from New York, but I'm currently living here at Stockholm. I work for Spotify as a security engineer. Side note, we're always hiring. I got into security because I like taking things apart, like I'm sure a lot of you do. So now we're going to dive into the problem. Spotify recently switched from using all of our own data centers to using Google Cloud. And to understand why we needed to make the switch, we need to look at the scope of Spotify. We currently have 150 million users. We stream about 1 billion songs a day. We also have a few thousand employees. We like to give all of our devs ownership over their own stuff. So to be successful on any given day, the security team needs to keep our 150 million users safe while allowing them to stream all their songs, and we need to let our employees release stuff to keep innovating for our customers. So to kind of understand why our data centers weren't working, we're gonna look at some pictures. So we had 2 data centers. It was great. We had some complexity. It wasn't so bad. They were pretty fun to run. And then we had 4 data centers. Still some overhead, still kind of fun. And then we had a lot of data centers and a lot of resources going into them. So we decided to switch. We wanted to ensure our users could keep listening to music, our engineers could keep releasing. Everything was going well, except for security. Honestly, switching to GCP was like a business decision. They kind of came to us and said, "We're switching. Here you go. Figure out how to fix this." Yeah. So, and also, GCP was a newer competitor in the cloud market. Their security tools are still being defined in ways that AWS, I think, already kind of figured out. So there were a few things that concerned us that we really wanted to let Google deal with. There were certain things like intrusion detection that we were like, Google's generic solution will really work for us. But there were other things like visibility into objects that we were super concerned about. Because of our really specific engineering culture and all the power we give our engineers, we were worried that what Google would come up with was going to be too limiting. And so we really needed the visibility of a tool. We really needed visibility in a tool so we could see what our engineers were doing, but we didn't want to limit them. So since we aim for this operational ownership by all the dev teams, and we really aim to not control environments, and we really want to use our influence to help our teams and raise awareness, we were pretty concerned about the tools Google was giving us. We like to we need to be so specific with the tools because we put a lot of trust in our engineers. We kind of understand they're going to make mistakes, and we really use the trust but verify model of doing things. We believe this approach helps so much because it makes our engineers really security conscious. And honestly, no matter how many tools Google gives us, if we have all thousands of engineers concerned about security, it will help us so much more than any tool. So we really just try and enable people, and we're really trying to put our time and effort into non-invasive procedures to help us gain visibility and not limit anything. So in a collaboration between us and Google in an effort to gain this visibility, we built a tool called Forseti. It's open source. You can find it on GitHub. And there were a lot of reasons we wanted to work on this with them. Number one being about how we treat our engineers and our concerns, like I was just talking about. Number two being Google has a lot of cloud-specific knowledge that we didn't have. Three being we had a lot of security-specific knowledge, especially specific in terms of a company of our size and what we needed. Google has a ton of security knowledge, but they're usually dealing on Google scale, and that didn't always translate into what we wanted. Number four being our engineers were using this. We needed a solution fast. Working together was the fastest way to get something out. So what is Forseti? Forseti is a open source toolkit to help us secure objects in GCP. So basically, it's a modular collection of open source tools to secure GCP resources and to monitor GCP environments. For those not familiar with GCP lingo, an object is pretty much anything you make, anything you might pay a cloud provider for, whether it's a VM instance, a bucket, a service account, really anything. So we had a few main goals going into this project. One is we needed a concept of rules. The rules need to tie to specific GCP resources, and we needed like a behavior associated with that resource. And since all the resources are different, we needed to like hand code specific behaviors for every single possible API call. So this is going to be labor intensive to make this. Our needs also change over time, so we want to be able to change the rules, even though the actions were going to be coded into this. Second, we really wanted a default allow policy for almost every single rule. We really didn't want to stop anything. We just wanted to know whenever engineers would open up buckets for the entire world. We also wanted to make sure we had a really good notification system. So we've noticed the security team at Spotify is pretty small, and we've noticed that if we turn up notifications too quickly, they just get ignored. And that would be really bad, especially if we're dealing with like pretty sensitive information that could possibly be exposed. So we needed to keep notifications low enough or come up with a system of like bypassing our team for the notifications altogether. So this was basically the architecture we came up with. There were 4 main pipelines. We have the inventory, the enforcer, the scanner, and the notifier. Those are the big boxes in the middle, and that's like the code we were writing. Then we store and access all our information in a Cloud SQL database, and then we get information from GCP, from like rules and configs, and then we send information out, originally via email, but now we've hooked in some other things like Slack. So what would happen when we want to run Forseti is the inventory starts, it grabs information from GCP, and then it basically takes GCP objects and puts them into the SQL database. Then then the scanner goes and it takes GCP objects and it takes rules and config files and it compares them, see which ones break the rules, and puts the things that break back into the SQL database as violations. And then the enforcer goes, and the enforcer goes through the violations and it goes through the rules and the config files, and it automatically pushes changes back to GCP. And then the notifier goes, and it takes the violations that were not affected by the enforcer, and it sends out violations to the teams that need them. We're going to dive into now more of each part. So in the inventory, this is where we scan all the objects we're using. The goal of this step is to create a snapshot of the current state of GCP. The inventory we have in the pipeline in the inventory we have pipelines for each GCP resource, and there are a lot of different types of GCP resources. So we make API calls for each type. Each type of resource has different fields, so each pipeline addresses those specifications. And each object from each pipeline gets stored in a table of that type of resource in a SQL database. This means that the SQL database, we have a snapshot of the state of all of our resources on any given day, which we found has also been really useful for other things, like not Forseti things. And we can also turn on and off each pipeline individually. So if I'm trying to test this locally, I can only run the pipeline I'm building. Or if we're nervous about something, then we can run it faster for a single pipeline. Google had people create icons for the different pieces of this. So that's the that's the inventory icon. Yeah. After this, we have the scanner, and that's where the rules come into play. So the scanner takes a set of rules that anyone can put in a Forseti config or that you can customize for your own organization. And then it goes resource by resource and scans each object in the SQL database. Most pipelines have at least one scanner. Some pipelines have more than one scanner. This usually happens when the API call returns something that then has types of types, and then we'll make 2 scanners for that pipeline. Then we pass in the correctly parsed object to another object where it compares the rule to the original config file. And there the rules are set up to determine 2 things. They can decide what objects to enforce on and what exactly to enforce. So for example, like you might want to have a bucket object, and you can say, like, for all users, they need to be authenticated. And you also might want to have an object that would say, for all folders, you might need you can't have a service account as owner. The second part of the rule is what to enforce, and it changes based on what GCP objects the rule is for. The rules see if the object, or the rule books, see if the object is the group that should be enforced and checks if the object breaks the rules. And if it breaks the rule, we send a generic violation back to the SQL database for further processing. The enforcer enforces certain rules. We define how rules should be enforced in a YAML file. And when the enforcer goes into the violation database and gets violation types that are defined and enforced in the configs, the enforcer then makes an API call to correct the misconfiguration. The enforcer is still a work in progress, and the only thing that we at Spotify enforce is firewall rules, which kind of makes sense because we don't want random engineers changing firewall rules, but that's about the only thing that we enforce. Right now, the enforcer works silently, which is a problem because like at one point, people on the security team were trying to change firewall rules, and it wasn't working. It was the New York team, and they email us like, oh no, what's going on? Why won't these firewall changes stick? And it was because we had in Stockholm, had put the enforcer in place already. It's wasted a few hours, but it works. The last step is the notifications. And the notifications go through the violations in the SQL database. And then Forseti automatically looks up the owners of the specific object. We can use Google APIs to figure out the owners for any object. And then the emails go straight to the teams that violated whatever policy we put into place. The teams usually acknowledge them and fix them. And the next day, if the violation has not been fixed, that's when security is CC'd on the violation emails. This really helps. I think this is the least technical, or this was the easiest part to write, but it was also the single most important part in making this useful for our team. So now I'm going to go through like what misconfigurations we have set up and kind of what are the security implications of those misconfigurations. First, the first set of rules that we wrote were things for data storage. This was kind of a necessity. We had no way of searching through all projects at once for like any type of objects that did not have any access permissions on them. And this was kind of scary as a team because every once in a while we'd dive into a project and we'd see all of these buckets open, but we couldn't really find them. And then we ran for Forseti the first time and we could find them. And it was awesome because of the visibility it gave us. So this is basically 3 sets of rules. It covers BigQuery that a lot of our analytics and data teams use. It covers buckets, which everyone uses. And it covers Cloud SQL, which some people use as a database. It's crazy how often engineers accidentally open up their own permissions for their data. We have a lot of data engineers in our organization, and they all own their own data. And so, for example, like a lot of our machine learning engineers are using BigQuery, and when they want to share their data with their coworkers, they'll click on like share permissions with everyone, and they'll think that means share permissions with everyone at Spotify. Yeah, we can't take away these resources from the engineers because we don't have the bandwidth, and we don't really have the desire to. If we took away the security controls from them, they wouldn't feel this ownership of security, and they wouldn't want to fix their own stuff. Now we have a lot of projects that we can search on. We can figure out whenever anything is public immediately. We can notify people immediately. Yeah, it's pretty sweet. The next are permission roles also, but kind of a different type. So teams own their own resources. They can decide who can be added as owners to their own resources. So this means that when someone new joins your team, if you have like a team IAM group, you can add their email. But this also means that if you're an engineer and you always forget your phone, and you're YubiKey, you can add your personal email so you don't have to go through two-factor auth, which is like, yeah. So these rules basically stop anyone from doing that. We can make rules that say only Spotify.com emails can be added. And we can also make rules for who can own what type of thing. And this is really useful because we want to make sure we can hold owners accountable for their projects and for their folders and for their buckets. And if like service accounts own things, then we can no longer hold them accountable. And we can get lost trying to chase people down. Next, we have network rules. And so these are meant to monitor which projects and which instances are talking to external things. We create a whitelist of what can talk out to external networks, and if something talks out, then we alert. We also, this kind of includes firewall rules that actually started as a different open source project, but it was kind of merged into Forseti. This one we don't get alerted on so much because usually people know this is dangerous, unlike the other two. Well, for people usually, this one gets alerted on the most because people do this by accident all the time. People usually know when they're doing something wrong with permission rules, but they kind of think they can get away with it. This we don't actually get alerted on so much, but it's really bad. Like, we really don't ever want to get alerted on this. So so how does this actually work now that we have everything in place? And now that you know all about the architecture, and that you know about what our engineers are doing, and then how we watch over what they're doing. Okay, so Forseti runs every day. The enforcer immediately fixes anything we set it to fix. The notifier sends out a mail to first-time offenders. We usually try and make this mail really friendly. We send them the project and the name and the team, and we tell them it's not a big deal, but it needs to be fixed like right away. Based on the type of violation, we send them an internal link of how you can fix it. And this is usually enough. 9 times out of 10, nothing comes to us. We don't hear about these. It's fixed. If we could see them, if we go into the SQL database. So we can see one violation from that day, and the next day it's gone. And then sometimes they email us excited, and they're like, oh, I fixed my own stuff. I own security for this project. And then we email them back like, good job, thanks, high five. And that's good too. It's a really good, I think it's really important to make sure everyone in your organization cares about security. But then sometimes they don't reply, and it's not so good. And then we send them like an angrier email, and that usually works. And then if it doesn't, one of us needs to get involved. Sometimes it's usually, when this happens, it's because we don't have a proper owner, which is why now we're creating all these rules about proper ownership. But yeah, we can usually figure it out. So what did we learn? Engineers have a lot of legit reasons to do seemingly sketchy things. When I started, I assumed there would be not so many violations because most engineers would know not to do anything wrong. But now I've noticed two main categories of violations. One of them is like Carly's test project 2. And it's just that. It's engineers who are like, oh, here's a button, I'm going to click this and see what happens. And they get an email from security so that they know we're always watching them, and it's all good. The other is people who have legitimate reasons to break our rules. And this is also good, because when they get the email from security, they just email us back, and they're like, hey, but like, I'm trying to make this website go live, and I need this image from this bucket. And we're like, yeah, of course, that's okay. Yeah, they're happy because they were able to do their job without having to go through excessive security checks. And we're happy because we were able to have an approximate understanding of what's going on without feeling like we're being overbearing. We also learned that auto notifications are like the small, simple piece of this puzzle that's the most important part of it. There was a point when we didn't have the notification pipeline in place, and I think most of the security team muted the notifications. We had malfilters. It was too much. We were getting a lot of emails, and emails just get lost. And so I think that was a really big learning for us, was to make sure we factor that into the design process more. But also, like any organization, you guys can set up Forseti. It's super easy. And it's pretty fun. It's fun to work on. Yeah, so I just want to thank everyone who worked on this from both sides, from us and Google's side. If you want to learn more, you can follow me on Twitter or email me. Also check out the GitHub page. Yeah, thanks.
Thanks, Carly. That was awesome. It's really nice to see that there are actually security projects relating to the cloud. Not that many that we see, but
yeah.
It looks awesome.
There's been one other by a company in New York, actually, that does a similar thing since we released this. But yeah, there's a lot of need for open source Google security projects that they're working on, but they're not working on fast enough. So
you got to help them.
Yeah, it's kind of our job.
It's awesome. Yeah. We actually have 4 minutes on the time, so we can take some questions from the audience, and we got one there. So.
Yeah.
Hello.
Hey.
I wonder, is this helping you to stop shadow IT?
To stop what?
Shadow IT.
Yeah.
Do you know that it's stopped? I mean, people can set up their own Wi-Fi and own network connections and so on.
Yeah, I guess I'm not really sure. We haven't, I'm sure there are ways to get around it if you tried. This definitely isn't, if we have a sophisticated attacker, they're going to get through some of these.
But they're happy.
Uh-huh.
They're happy with this and they can work.
Yeah.
Yeah, thank you.
So you got the enforcer enforcing rules on the rules for the enforcer? So if someone changes the rules of compliance for this, no.
Yeah, so the enforcer enforces, we have this one big SQL table of violations, and then we have a config that tells the enforcer what type of violations to pick out. And then it just kind of picks out those violations, and it just sends API calls to GCP and changes them. Yeah. But we don't really like the enforcer. The enforcer is, it's not that it's bad, it's just it kind of goes against everything we believe in as a security organization at Spotify. So unless it's really serious, we try not to use it. Yeah.
All right, more questions?
What's your biggest wish for Google Cloud in terms of security?
That's hard. I wish Google would make all their internal tools available externally, I think. Because we talk to their engineers, and they tell us they have things, and then we go and ask the people, we deal with two people, we deal with the engineering teams and the sales people, And the salespeople tell us things can't happen, and the engineers tell us, oh, like, we have that. And it's like, no.
All the way. I see one all the way in the back. You gotta run. Run, 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 run.
So what was the first week after rollout like? Was it, did you have time for anything else, or I just assume it's not like going to be 0 alerts on the first day?
Yeah, the first day was hectic. It was... it was really scary also because you would be testing it. So you'd be coding, and then you would test it for the first time, and it would work, and you'd be happy. And then you'd be like, oh no, like, we need to go find all these teams right now. Like, this can't wait until we push this. Yeah.
Okay, you gotta run all the way. Okay.
Yeah.
Have you considered expanding this for the Microsoft Azure or the AWS, Amazon?
AWS has something very similar. So AWS has Scout too.
Yeah, I know, but especially Azure. That's the problem.
Yeah. No, we don't work on Azure, and it's I mean, the architecture is similar for all of them, but it needs to be so specific because of the API calls that it's hard to translate into another system without putting in a ton of effort. Yeah.
So it's not in the near future.
No, another security team could work on it though.
More questions? No, okay. So first of all, thank you so much, Schneider.